Okay, in case somebody's watching and they want to see, this is problem H from your worksheet. All right, you tell me what to do first, folks. Good. 3 over x minus 1 minus 4 over x minus 1 over 1 is greater than or equal to 0. So, I heard create common denominators. I like your idea. So what should I multiply the top and bottom here by? X. Good. Top and bottom here? Top and bottom here. Okay. X times x minus 1 or x squared minus x. I'll write it as that, trusting that everybody can see that. So this is one of those times, and again, part of the reason we're practicing this is, number one, for inequalities, but number two, this is kind of a summation of all of your algebra skills. Factoring, fractions, multiplying, dividing, solving equations, plotting number lines. It's a lot of those skills put together, so it's good review for you. People make small mistakes. Let's look at the top. 3x, what? Minus 4x plus 4 minus x squared plus x all over x times x minus 1. So, super important that you keep that organized. All right, let's look and see what happens. If we combine our x's together, what do we get? Nothing. You're left with 4 minus x squared. You have a couple options at this point, but I would encourage you just to factor it at this point. Does the top factor? Can't we just go 2 minus x and 2 plus x? Yes, we definitely can do this. I'm not trying to mislead you, sorry. I've lost your trust, haven't I? I've broken your trust too many times. Like, oh, Mr. Gens, you're mean. All right. So what numbers do we plot? Excellent. So how many columns will I have? A lot. YouTube, they said a lot. Yes, you'll have 5. How many rows? And let's just recall that up until this point, like this part right here, you're creating common denominators, working with fractions, factoring. That has been skills that we've learned in previous years. Not meaning it makes it easy, but we do have reference for that. The part that's very new is this now, right? On the sides, we put 2 minus x. We put 2 plus x. X and x minus 1. What number would you like to plug in? I heard a -3. Look at how quickly you guys are rolling through this now. I don't know if you've realized, but you've gotten a lot smarter over the past couple weeks. Good for you. I plug in -3. Do I get a positive or negative? Positive. Negative, negative, negative. 3 negatives make a... I don't care about the positives, do I? Do you have the worksheet? Just concerned about my buddy and his learning. Oh, it's okay. No. People interrupt me all the time. You're welcome. All right, so now what number am I going to plug in? And I get a positive, positive. Now what number? Should I plug in 1? Why not 1? I like 1.
Because it's the number you get.
Yeah, you can't plug in these numbers, folks. You got to plug in numbers between them. So I plug in 1/2, and I get a positive, a positive, a positive, and a negative. What about between 1 and 2? 1.5, 2 minus 1.5 is a positive, 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 positive. Well, they're all positive. Sweet. Then we want to plug in 3. Oh, 2 minus 3, that's going to be a negative. Am I wondering where this is positive, or am I wondering where this is negative? I am wondering where it's positive because it says, where is it greater than or equal to 0? Where is it greater than or equal to 0?
0 and, I don't know.
Because I have an equal sign, do I want to use brackets or parentheses?
Do a bracket, and then you do a parentheses because it's on the bottom.
Good. So I use brackets, but is that correct? No, because I can't put a bracket on which numbers? The ones that give us 0 in the denominator. So 0 has a parenthesis, and 1 has a parenthesis on it. And that would be the final answer.
Right. So it's just the ones that make 0 at the bottom.
Yes, if you see an equal sign, then we say brackets. But you must exclude the ones that produce 0 in the denominator. Why? Because 0 divided by 5 is 0. It's okay to have 0 in the numerator. 5 divided by 0, that's in the denominator. That is what we call undefined. We are not allowed to do that. That's why we exclude those values. 0 divided by 0, that is, we don't know. We need calculus for that. All right. So, I don't want to take away from your joy of working through this and working through the challenges. Again, part of the reason you have this is you need the practice of the algebra. So the next few assignments we have, lessons, they're easier, but you need to keep this on the front burner and continue to work through it. I would say you for sure do not want to go into this weekend not having this finished. So if you're still catching up this weekend, come in and see me, and let's make sure we go over some of these questions together. That said, take out your notes, and let's look at something easy today. Okay, so we dealt with the inequalities. There's really two topics of this next section. We had inequalities, and then we have what we call coordinate geometry, and that's starting to work with the x and y axis and plotting things and whatnot. So we're going to start with the distance formula, and the distance formula is the root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1, that quantity squared. You've seen this before. This should be reviewed. Doesn't mean that you remember how to do it. Doesn't mean you won't make mistakes, but it at least should be familiar. So I'll do some teaching as we do this first example. It says a pair of points is given, plot them, and then find the distance between them. Okay? As well as the midpoint. We'll talk about that in a second. I'm going to make a nice graph here, and I'm going to go 6 by 6. Just heard the I don't like graphs, I hate graphs talk. It's very normal. People say that a lot. I can't relate to that. Graphs are what made... I think that we all argue that we're visual learners, but yet we don't like graphs. To me, those are contradictory statements. Part of the reason why I like graphs is it makes me see the mathematics. I can visualize it and I can understand it better. So I was always a big proponent of graphs, but I learned that I was in the minority. So, all right, so I'm going to plot -2, +4, +3, -6. And I'm going to connect those. So we have a segment joining those two pieces. -2, 4, and +3, -6. Is everybody okay with my little graph? Okay, so I would like to find the distance between them. And instead of using the distance formula, I would like to show you where the distance formula comes from by making a nice little shape here. So it turns out that the distance formula comes from your ability to find the hypotenuse of a right triangle. Anybody know what what theorem we use in order to find the Pythagorean Theorem? So work with me here, folks. If I started up at +4 and I dropped to -6, what is that total distance? 10 units. You took x sub 2 minus x sub 1. You took -6 minus 4, didn't you? You got that 10. Actually, it's -10, but if you square it, it becomes positive. And then how about this one right here? If you start at -2 and you go over to 3, how far of a distance is that? 5. You took y2 minus y1. So if we want to solve for this distance, what would we do when you use the Pythagorean theorem? Yep, a squared plus b squared is equal to c squared. So 10 squared is 100. 5 squared is 25. So 125 is d squared. Square root, exactly. Is there a perfect square that divides evenly into 125? Yep, 25 goes in 5 times. So we have 5 roots of 5. So I hope that if you look back at the distance formula, I hope that you can see we have a squared plus b squared, and this square root, it would actually be a d squared. It just went away when you took the square root of both sides, so you would have a c squared over there. A squared plus b squared is c squared. It just comes from the Pythagorean theorem. You see, nothing we do in mathematics is made up. It all stems from other pieces. That's the beauty of it. That's why people like it. Okay, so let's use the distance formula here so you can get the practice if you don't want to actually make the graph, since you may be opposed to the graphs. So we have d is equal to the square root of, where do I start? Very good. -3 minus 2 squared. Is it a plus or minus symbol then? Plus, because Pythagorean theorem, a squared plus b squared. So then what? 11 minus that -1. Good. So if you prefer to use the formula, there you have it. On the ACT, they generally produce a graph. I would not use the formula. I would count and use the Pythagorean theorem. But if you're just given the 2 points, a lot of times you just go to the formula. So distance is equal to the square root of -3 minus 2 squared. Yep, 11 minus -1 is 12. Squared is 144. So we get 13. Everybody okay with the distance formula? Okay, so let's talk about the midpoint formula. Suppose my friend Sydney bought a pair of shoes for $40, and suppose my friend Maddie bought a pair of shoes for $200, okay? So, and I want to find the average price that they spent on their pair of shoes. How would I do that? I'd add them up and divide them, right? So 200 plus 40 is 240, divided by 2 is $120, okay? All right, so $120 is what we spent. So if you want to find the midpoint, you do the same thing. You add them up, and you divide by 2. So to find the average of the x values, add up the x values and divide by 2. And I have a comma because you're actually finding a coordinate. So the midpoint formula produces a coordinate. It produces a coordinate. So let's do that for A, and then you'll do B on your own. And this can be pretty quick. Let's look at our x values. What do you get if you add those x values together? 1 divided by 2. The y values. Add them, and I get negative 2 divided by 2, negative 1. Now, as you look at my graph, does it seem reasonable that the midpoint could be 1/2 negative 1? Yeah, my graph isn't perfect because I make mistakes all the time, but it's close. Seems reasonable. Go ahead, find the midpoint for letter B on your own. For the next one, you should have negative 1/2 5. Are we okay with that? Questions there? What's that? Given the circle as center, HK, radius R, the standard form from the circle can be written as the following. Go back to your notes. Nope, don't have time. Don't have time to draw the triangle. We'll just have to miss that question on the ACT. Okay, so an equation for a circle, you guys are familiar with this, right? Y equals mx plus b. But there was a time where you saw it where you're like, oh, I don't really know what that means. But now it's just become second nature, right? And the same thing is going to happen with your equation for your circle. I know right now it looks really complicated. We're going to make it super simple today. Maybe you're familiar with this one. Y equals a times x minus h, quantity squared, plus k. So I get it. Some people don't remember it. You did have it last year, Chapter 5 in your Algebra 2 class, where you're graphing parabolas in standard form. So that's one that you got used to as well. Kind of forgotten about it. We're going to bring it back this year. And it's important because there's going to be a time where you get this. Y is equal to negative 3 sine of 3x minus pi over 4 plus 2. And you're going to be able to graph that. In fact, believe it or not, that ends up being the best scoring test of the entire year. Half of you guys will get an A+ on that test. And yet it looks super complicated, doesn't it? Well, that's just because you haven't learned it yet. It's really not that bad. Just like this is not that bad. And I will show you, and the reason why we're covering it now is it has everything to do with the Pythagorean Theorem. Do you see that this is kind of like a squared plus b squared? See that? In fact, watch what happens. It says if the circle has center 0, 0, the center is your hk value. So we're going to plug in 0 for h. If you plug in 0 for h, what does this expression become? X squared. If you plug in 0 for k, what does this expression become? Y squared is equal to r squared. Now, I know I ask you to take a stretch every once in a while and you're thinking, if you can't see how x squared plus y squared is r squared is similar to a squared plus b squared is c squared, just got to change the letters a little bit, right? Like that's it. Okay. So So they're pretty much the same. So let's get you used to working with circles, okay? It says write an equation for a circle with the following properties. Center of -3, +2, and radius of 4, okay? So these will be points on the test where these will be 98% of the people will get these questions right on the test, okay? These end up being super simple right here. What we do is we say that's H, that's K, and that's R. And we just plug it in. And we get X minus -3 squared plus Y what? Minus 2 squared is 4 squared. Now, we don't leave it like that because we don't ever write minus and negative. Instead of X minus -3, we write what? X plus 3 quantity squared. And then Y minus 2 quantity squared is 16. Now, what's important for you to get used to as you look at this is to be able to say, hey, I see the -3 and the +2, but right here it looks like +3 and -2, doesn't it? It's opposite of what you think. You see the -3, +2, here it's +3 and -2. It all happens due to that subtraction sign, okay? And then you can see the radius is 4, yet there's a 16. It's whatever the radius squared is. So watch as that happens here as well. Here I have an x value of 0. So what's x minus 0 squared going to be? X squared plus, and then it's y minus -5. So what's that going to be? Y plus 5 squared equals, and then what do you get if you square a half? A half times a half is a fourth. That's the equation for a circle with the center 0, -5, and a radius of 1/2. This one is going to be x what? Good. Plus y squared equals this is where we fall apart. We shouldn't. We got to just kind of stay level here. If you take that and multiply by itself, that's what it means to square something, right? So 3 roots of 2 times 3 roots of 2 is 9 roots of 4, or 9 times 2, which is 18, okay? So that's something we could definitely do. Let's switch it around. If you saw an equation for the circle, could you identify the center and the radius? What's the center here? 3, -2. Awesome. Opposite of what you thought, right? Opposite of what it looks like. What's the radius? 4. What's the center here? 0. Good. And how about the radius? Square root of 48. Good. So square root of 16, square root of 3, so 4 roots of 3. Excellent. Not too bad, huh? So here's the catch. It's to show that the following equations represent circles by placing them in the standard form. This is a circle, but when you look at it, you can't tell the center or the radius, can you? And the reason why is because it is not a completed square. It is not a completed square. Notice the form all has a completed square. And so, someday after school we'll go over it. So, how does it go? Very simple. We gather the x's, x squared and -8x, and we gather our y's. So I've taken care of all the terms except for one. Which term have I not taken care of yet? What do you think I do with that? Excellent. So there it is. So I have the same exact expression. I just stretch things out a little bit, and I put the 7 on the other side. So I need to complete the square. Who can remind me, what do I do with this number right here? divided by 2 and square. Now, I think that that's something we can all do. We take this, we divide by 2 to get 4, square it to get 16. If I add 16 to one side, add it to the other side. How about here? Yes, 12 divided by 2 is 6, squared is 36. Any question there so far? The square is completed. If you can do that, you're golden. What does this factor down to? X minus 4 squared plus y minus 6 squared equals 59. So now we need the center and the radius. What is the center? Radius? Go to 59. I guarantee you'll have at least one question on the ACT that will be around circles. Around circles. Nobody laughed. It's all right. It's kind of around. It's like round. That's all right. I don't have any x's to gather, do I? I just have the x squared. Is that a perfect square? So I'm good to go for the x's. Isn't that a nice problem? Plus y squared minus 6y. What do I do with the negative 7? Okay. Plus 9. 9. Chalmers is rolling. He ate his Wheaties for breakfast. So I now have the completed square. That's the goal. We roll through the completed square process. We now can identify the center, and we can identify the radius. What is the center? 0, 3. What is the radius? 4. Piece of cake, upside down. You don't know? Last one. Find an equation for a circle whose center is negative 1, 2, and passes through the point 7, negative 13. Center is negative 1, 2. Can I use that information? Is that useful to me? So how does it start out? Sweet. Do I know the radius? Oh, quick chat with those around you for 20 seconds. What could you do to find the radius? Go. Okay, so what's your thought? What do you do?
Well, isn't there a formula for radius?
Oh, if only we had a formula. Was that? I like it. The distance formula. Yeah. Sweet. So all we're wondering here is, if you think about it, we're wondering the distance from the center to a point, right? So we're wondering distance. Have we taught you a formula today that tells you how to find distance? Oh, yeah, we did. So let's just use that real quick, and we'll figure out the distance. So Morgan said do square root of x sub 2 minus x sub 1. X sub 2 minus x sub 1. Then what? Which is negative 13 minus 2. Very good. What is 7 minus negative 1? 8 squared What is negative 13 minus 2? Squared? What is 225 plus 64? Square root of 289? 17. So, true or false, I put 17 there. 17 squared, right? 289.